on systems that handle pressurized liquids. To understand how a typical relief valve works, let's start with its basic parts. The outer shell is called the valve body or valve casing. It gives overpressurized liquids a path to flow through, as well as holding the internal parts of the valve in their proper position. A look inside the valve body shows the inlet and the outlet. On this particular valve, the inlet and outlet are both threaded. The threads enable the inlet to be connected to the system, and the outlet to be connected to discharge piping. In many high-pressure applications, though, the inlet might be flanged or even welded directly to the system the valve is protecting. When system pressure is normal, the path from the inlet to the outlet is blocked by the disc, also called the plug. Liquid is prevented from leaking around the disc by firm, even contact between the disc and a seat. In some valves, the seat is a permanent part of the valve body. In others, a threaded seat bushing is used. Because it's threaded, a seat bushing can be replaced if necessary. Guiding the up and down motion of the disc is the spindle or stem. Often, it too is threaded so it can be screwed directly into the disc. To hold the disc in place against normal system pressure, a spring is used. A spring washer forms a flat surface on top of the spring to ensure even contact between the spring and the adjusting screw. The adjusting screw fits down over the end of the spindle and screws into the valve body. This screw exerts downward force on the washer and spring and can be used to adjust the tension of the spring. A lock nut holds the adjusting screw in position once it's been set, and a cap covers the top of the assembly, protecting the internal parts from dirt and damage. That gives us the basic parts of a relief valve. Now, let's see how a relief valve works. Let's assume that normal system pressure for the system this valve is protecting is 18 psi, and that the valve is set to open at a pressure of 20 psi. When system pressure reaches 19 psi, nothing happens. Pressure is still at a safe level. At 20 psi, though, the system pressure pushing upward on the disc begins to overcome the tension in the spring. The disc begins to lift off its seat, releasing pressurized liquid through the outlet. At 21 psi, the pressure lifts the disc even higher, and as pressure increases, the disc continues to lift until it has risen as far as it will go. This particular valve reaches its fully open position when system pressure reaches 25 psi. The difference between the pressure at which the valve begins to lift 20 psi and the pressure at which the valve is fully open, 25 psi, is called the accumulation of the valve. We say then that this relief valve has an accumulation of 5 psi. Another term you should know is lift or travel. Lift or travel is the distance the disc moves from its closed to its fully open position. In this valve, the lift is about 1 inch. In other relief valves, lift ranges from fractions of an inch to several inches. The valve has done its job. It's relieved excess system pressure. Now, let's watch what happens as system pressure returns to normal. As pressure decreases, the upward force on the disc decreases. Thus, the tension in the spring gradually gains the advantage again and moves the disc back down toward its seat. At 20 psi, the pressure at which the valve began to lift, spring tension and system pressure are equal. The disc is reseated. When pressure drops further, spring tension completely overcomes system pressure, firmly holding the valve closed. You can see how important proper spring tension is to the function of a relief valve. But, like any other component, springs wear after extended service, losing some of their stiffness. This changes the opening and closing point of the valve. To correct this, the spring adjusting screw can be tightened. This increases tension on the disc and raises the opening pressure of the valve. Loosening the adjusting screw has the opposite effect. It reduces the amount of tension on the disc, allowing the valve to open at a lower pressure. Remember, though, that each relief valve is designed to handle a certain range of pressures, so each can only be adjusted so much. So, before making any adjustment to any relief valve, consult the manufacturer's instruction manual. Know exactly what you're doing before you do it. I mentioned earlier that relief valves are used primarily on systems that handle pressurized liquids like cooling water, lube oil, and fuel oil. For gas and vapor systems, you'd normally